All right, so in the guided notes for today in section 4.5, we're going to continue with slope-intercept form. So the first thing we'll do is just very simply kind of review the format here. So the linear equation of y equals mx plus b is written in slope-intercept form. Okay, so obviously which one I'll just put here. M is your slope, and B is your y-intercept. Even put it in the format of 0, comma B. So that's always your y-intercept. So B. So if we think back to math by fives, and we did this equation here. It says here slopes 2, y-intercepts 1. This is where you start. This is where you go. So the slope will be written as 2. As a fraction, you write it over 1. So you go up to right 1, up to right 1, and then go down to left 1. Like that. Okay. So in the first example, we're just going to identify the slopes and y-intercepts. So you notice here the first one's pretty easy to identify because it's already in slope-intercept form, part A. The second one's going to take a little bit of work because it's in standard form, ax plus by equals c. So really, we can just go right to the answer for part A. Now, the equation is in the form y equals mx plus b, or slope-intercept form. So the slope of the line, interesting enough, there is no number there. So what would the slope be there? 1, because there's an assumed 1. And then the y-intercept is 3. Moving right along, let's say we try this next one. So we have to rewrite the equation in slope-intercept form by solving first for y. So I think at this point, most of us are pretty good. So the first thing we're going to do is add 2x to both sides. You're left with y equals 2x plus 5. Oh, that's the only step. So that is our equation in slope-intercept form. So now we can have say that the line has a slope of 2 and a y-intercept of 5. All right. So at this point, I want you to pause the video and try these 4 checkpoints. Again, it looks like only the first one's in slope-intercept form. The other 3 are in standard, and you have to change it. So please pause the video and put these in slope-intercept. I'm sorry, find the slope and the y-intercept. All right, so if you did it right for the first one, you should have got, my bad, sorry, trying to do one at a time here. The slope is 4 over 1, and the y-intercept is -1. For the second one here, you had to put it into standard form, slope-intercept form, so -4x on both sides, and then divide everything by -2. That's your equation. So your slope was 2, and your y-intercept was -4. Number 3, this was so close to slope-intercept form. You just had to divide everything by 4, and now you get a fractional slope of 3/4 and a y-intercept of 4. So there's your answer there. The last one took 2 steps to put into slope-intercept form. You -6x on both sides, divide everything by 3. There's your equation in slope-intercept form. So your slope was -2 and your y-intercept was -7. All right, moving right along here to page 37. Let's do this second example here. Graph the equation using slope-intercept form. So this is where you start and this is where you go. But before we do that, we have to put it in slope-intercept form. So the first thing I'll do to this is just, it's only one thing really, just because the y is already isolated a little bit there. So -4x on both sides. You're left with y equals -4x plus 2. Right? The next step is to identify the slope and the y-intercept. So the slope is -4. That's your m, and mx plus b slope. And then y-intercept is 2. So the next part is plot starting point, which the point that corresponds to the y-intercept, which is 2. So as a coordinate, we'd write that as 0, 2, because x is equal to 0. And so we go ahead and plot that point here. And then use the slope located at to locate a second point and draw a line. Better than a second point, I've tried to do as many points as possible. So m here is -4, and we write -4 as -4/1. So now here I'm going to go down 1, 2, 3, 4 over 1. You know, it goes off the graph. I'll go 1, 2, 3, 4 over 1. Go left, do the opposite, 1, 2, 3, 4 over 1. Doesn't hurt. No one is gonna. There's no graphing police that's gonna come arrest you for going off your little graph there. So that's what that one looks like. Pause the video and try to graph number 5. Make sure you put it in slope-intercept form first, and see what you get for that graph. All right. If you did it correctly, hopefully you got this. So I added 1/2 x to both sides. I got 1/2 x plus 1. So now when I did where to start, I started at the y-intercept 0, 1, which is that. And then where to go, it was 1/2 slope. So I went up 1 over 2, up 1 over 2, down 1, left 2, down 1, left 2. Looks like that. So now this part of the video is going to get interesting, because now we're going to talk about what makes lines that are linear parallel. There's a very specific thing. It's either the y-intercept or the slope that are going to make lines parallel. So let's check that out here in this part of the lesson. Sorry, let me just adjust that. So we have 3 lines here. Okay, so we're just going to identify the slope of these 3 lines. Now, it looks like it wants us to do the slope formula. But when I see a graph, I don't even want to do the formula. I just want to do rise over run. So let's go ahead and I'm just going to do rise over run for each of these lines. So I'll try to color code it a little bit. So line A is this line here. Okay, so I'm just going to do rise over run. So I'm going to go up 1, 2, 3, 4, 5, 6 over 1, 2, 3, 4, 5, 6. So I'm just going to put this slope as 6 over 6, which equals 1. Okay, let's check out the next slope for line B. So line B, I will do in pink. I'm going to check out that slope, rise over run. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 6 over 6. The slope is 1 again. And then I'll do line C. I'll highlight that one in green. Get the slope for this one here. Right? So that slope, I'll go counting from here, rise over run. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I think this one comes out to 7/9. So now looking at their slopes, which can't be reduced, so it's just 7/9. So if you look, which 2 lines look parallel to you? Is it yellow and green, green and pink, or pink and yellow? Yeah, it's definitely pink and yellow. And so if you look at the slopes for pink and yellow, what do they have in common? They're the same. So we can then conclude at the bottom that lines A and B are pink and yellow, have the same slope, so they're parallel. So the moral of the story is if they have the same slope, they are parallel. I'll repeat that again. If they have the same slope, they are parallel. If you don't believe me, I can go to handy dandy Desmos here, and pretty much I can just put in a couple lines here for you to see. So say I do y equals, I don't know, negative 4x minus 2. Okay. Now, if I want a line that's parallel to that, I'm going to have to use the same slope. So what would the same slope be? Y equals, the slope is 4, so I'll put 4x plus 3. Again, those lines are parallel due to the slope being the same. If I want another parallel line, y equals, I'll just do plain old 4x. So there's another one. If I want one, let's make another one. I'll do a huge y-intercept. So I'll do y equals 4x plus 12. Again, the y-intercept's way up there, but you can see all those are parallel. As soon as I put one that doesn't have a slope of 4, maybe I'll do y equals, what's something close to 4, maybe 5x minus 1. You can see that black line is not, it's almost like the black sheep. It's not the same as the others. It's not the same slope. So again, if I just kind of look at two of the lines here and here like that, well, yeah, you can see eventually it's way, oh my gosh, where is it? It's all the way at the top. But eventually they'll intersect way at coordinate 60 something. They'll intersect. So again, they have to have the same slope for them to be parallel. So in the next part of the lesson, you're going to be testing it using the this checkpoint here. So again, but this we can use the graphs because they didn't give us the graphs. So let me just, before you start this checkpoint, let's get one of the slopes for line A. So we'll put, remember, just make sure you remember this. So this would be x1, y1, x2, y2. So then your slope would be, hopefully remember the formulas, change in y, so second y minus the first y. And then this one's change in x, second x minus the first x. And so this gives me negative 3 over negative 4, which is a positive 3/4. Okay, so if I keep the color the same, this is line A. Line B I did before. Well, sorry, in pink, and this one's line C. Just broke my highlighter. So I'm going to have you pause the video, and I want you to figure out which lines are parallel. And here again, you're looking for slopes that are the same. So good luck with that. All right, so if you did it right, hopefully you said A and C. So here's my work here. So again, you saw that 3/4 for line A. Line B came out to 5/7. It's not the same slope. And line C is also 3/4. So the correct answer is line A. And my broken highlighter here. It's disgusting. I don't need that anymore. And line C. So those two are definitely parallel. So I hope this got us a little bit more into slope-intercept form. Today you're going to try some classwork, and on the next pages 39 and 40. So